Okay. Coming on to data types, there are three different data types which are called as fundamental, derived, and user-defined data types. Fundamental data types are also called as primary, primitive, scalable. Let's say scalable data types. Derived data types are derived data types, and user-defined data types are also called as programmer data types, secondary data types, preferred data types. Okay. Uh, what is fundamental data types? A data type, what is a data type? Initially, when we say data types are the variables where we assign values to that variables are called data types. Okay, depending on the type of data, we assign the variables. Let me put it in this way to make you more understandable. Data types are nothing but if you have something in your hand, you measure something like weight with kgs, you measure liquid with liters, right? You measure what do we have, temperature with degree centigrade, you measure money with a standard dollars or something. So when you have something, you need to classify what type it is. So in our programming, what do we have? We have data, right? What do we have? We have data. We have data means data can be classified into on what type it is. So we call it as data type. Okay. So in programmatical way, what would be the data types? When we say how data types can be classified, so we can say integer is a data type. All the numbers, float means 0.00, numbers which are having point something is called a data type. String, a continuous characters, is called a string, which is one data type. uh, uh, and boolean means true false. These are also one type of data, right? We classify this is true, this is false. So these are the data types. Got it, Vishnu?
Yeah.
Okay. So why we need data types? For suppose if I am asking you to write a program stating print Ravi or print 1 2 3 4 5, so there should be some place where you should store the string, right? You would you should store hello welcome to Ravi. So this is a string. String means group of characters. So when you say this is the string that I need to display when my code executes, you should store those value somewhere in our code. So in order to store those value, depending on the data, because this is a string, you store in a string x equal to welcome Ravi. Okay. If I say store 5, 5 is a number. So you store it in an integer, int, x equal to 5. Depending on the type, we define the data. Okay. So when we say on the type, we classify them again into many data types like what you see on the screen, like fundamental, derived, and user-defined data types. The different. Let me define what fundamental data types are. The fundamental data types are those variables allows us to represent a single value where we are only one type of value. For let us say when fundamental data types, let me put it in this way. For example, let us say I have an integer 5. So how do I define this? In Java, we define it as integer equal to 5. Okay. So this is a fundamental data type where if you say int x equal to something, where x is always an integer, you can't place string in it. If you say I would place something like 5, uh, it won't accept it because 5 is a string here. Only placing 5 here like this is an okay. And or if you say I want to place Ravi, This is a string, but you declared here as int. So x is always an int and it expects an integer. So you cannot define a string to an integer, because you define int x means x would be always an integer. So fundamental data types are those where the type of the content is always unique. If you say x is a 5, x is an integer, it should be an integer. So different data types cannot be stored in x. That is called a fundamental data types. So fundamental data types can be defined as those variables allow us to represent only single value. Okay, we are unable to represent multiple values at same point of time. We cannot represent 5 and 6 in x at one point of time. Only one value can be represented at one point of time. If you want to define, let's say, if you want to define a string called Ravi, then you should write string y equal to in double quotes. String is always represented in double quotes. These are the syntax. You should remember them. String is always in a double quote. Integer is always a number. Okay, without any double quotes or single quotes. When you say character, it should be like char z equal to in single quotes. In single quotes, you should write only one digit character a. So string and character has a difference with double quotes and single quotes. Got it? C should be small. In string, S should be caps. In I should be small. Okay. This is how we represent a fundamental data type. So how you define a fundamental or primary or primitive data type? Data types in which only these are called variables. X, Y, and Z are called variables, where variables would be assigned with only one type of data. Multiple data cannot be represented in this. Okay, multiple values cannot be represented. Okay, where derived data types are those in which you have a chance of representing data of multiple values in one go. Like this, let us say I can represent string of multiple values saying RAVI, comma, Shankar, comma, Vishnu. So you are representing in a variable A three different same type of data. Type means all are strings, because you declared A as a string of array. Every value would be strings. Got it? So if I say int of C equal to, then I should represent this as 5, 6, 7 or 8. So C is called a variable, and the data that we assign to this, these are called data types. String, int, these are the data types. So how you assign? In derived data types, for same type of data, you can have multiple values. These are called derived data types. In fundamental data types, only one value can be assigned into the variable, and that variable we cannot have multiple values. Where in case of derived data types, same type of values can be assigned with multiple values, but not with the different types. When it comes to user or secondary or programmer defined data type, the variables can be like it can be like anything. Like you can define Shankar, comma 5, comma decimal points. Let us say I have only some of them will be having like 32.54. This is a different, right? It is not an integer, and you can also define false. Different data types. You can define single character in it. See, so these are the where when you say it is an user defined data types, depending on the user need, if he feels he want only string and integer, he can define a data type with string and integer. If he wants a data type with many, he can add any type. So User defined data types are those where the data types would have multiple different types of data can be added. Different types means string, integer, and multiple data also can be added. Got it, Vishnu?
Yeah.
Okay. Why we you need data types? You understood the concept, right?
Yes.
Yes. Why we Let me explain once again. Why we need data types is nothing but when you write lot of code, there would be place where you read some data and you should store the data into code, and you should process the data and manipulate and do something. Let us say I want to add two numbers. Okay, and I am giving those two numbers from string args, means I am giving it as an input to the code. So somewhere you should store that two values from them, and then you should display the value. How you store those? You store those using data types. Like int x, you will say 5. Int, then again you will say int y equal to 10. Okay, and then you want to find the sum again should be stored in an integer, right? Sum will say x plus y. So what happens? X is already 5. 5 plus 10 is, you will be stored in int z. So z is all again an integer. So if you print system.out.println sysout, then what you will get? You, if you print z, it will print you the value 5 plus 10 20. Got it? So data types are nothing but the way we represent data, what sort of data it is. So if it is an int, it is an integer. If it is a string, it's a string. If it is a character. Boolean, boolean means true or false, it's a boolean. So what sort of, so before how we declare these things is like int space, if you define some variable x y z, uh, is equal to, you can assign the value. Got it?
Yeah.
Okay. So this is a fundamental data type. There would be some places where you need to store lot of values of same type. In that case, you use derived data types. In some cases, yeah, depending on the requirement, there would be some chances like you need to create your own user defined data types. In that cases, what you do, you create your own data types and then assign the values into them. Like for suppose, let me say I'm getting a data such a way that personal details. Okay, in personal details, when you say this is a data, how can the data be? First, when you say personal detail, it would be a string, right? Your name would be a string, and next one can be age. Age is always an integer, right? So integer can be 32, and next one comes is male or female. It can be a character M or F. So let me say I am male or a female, and then date of birth. Date of birth can be again a time, like year, right? DDMMYY format. So for that, let us say I am taking a string. I will mention it with 0212201513, and again phone number. It should be a integer. Integer can be 10 digits, right? 9581262 5. Okay, and what else? Again, personal address. Address would be again a continuous string. Okay, so this is how we create data types. So in order to store different sort of data into one data, then we create user defined data types. Maximum, you would get very less chances to create user defined data types. You would be mainly using these fundamental data types and derived data types initially. Once you go into real time projects, there even we have many alternatives to create data types. Use fundamental, we have different methodologies like creating beans and storing the data and getting them. So this is what data types is. Now let me go into detail regarding what sort of fundamental data types we have. Okay, uh, let me start for fundamental data types. Okay, Vishnu, you are able to understand, right?
Yeah.
Okay. So fundamental data types, as I defined you, fundamental data types are those where you have represent a single value and where you cannot be represented multiple values into them. So fundamental data types are again organized or categorized into four different groups. Okay, they are the categories can be integer category means all integers are stored, float category, and next one is character, next one is boolean. Okay, fundamental data types are mainly categorized into four different types: integer, float, character, and boolean. Okay, integer category data types are mainly used to represent integer data. Okay, integer data type are used only just to represent the integer data. Like if you say integer category, we have, let me just put it in this way. For integer category, what data types we have is like byte. You remember byte in our, when we are small, when we are initially at the, when we learn about the computer, we say computer always compute data in bytes, bits, 0110. You remember it, right?
Yeah.
Yeah. So integers can be like bytes. Byte means 10. It can be represented only in 10 format. Okay. Uh, in integer category, we also have short. Short is nothing but in smaller values, and next is integer, int. We represent the data type as int, and one more thing is long. So in integer category, we can represent the data in four ways: byte, short, int, and long. Okay, and when we classify this, let me also put it in an even if you want to note down. Okay, this is the information which you need in integer data types. Let me create a table for you. Table. Four cross four. Okay, let me say serial number, and this is the data type, and this is size. So how much size the data type stores? We normally speak in the words called byte, in byte, in bytes. Okay, in bytes, and the range of values that it can store. Why we classified in integer, why we classified four different data types is like, depending on the range and on the type of integer, again we classify into four types. First one, as I told you, this is, okay, first one is like byte. Byte size is always one byte. Okay, one byte, like 101, only one, right? So the range it can store the value is 1272 minus 128. Okay, using byte means bit is like, bit means either 1 or 0. When you say bytes, grouping all bits together is called byte. Like representing binary format of a 2 is 101111. uh, you remember these things, right? Conversion of
Yeah.
a number into binary format, a decimal format or something, we use 10011110, like that. So byte can only store until the range minus 128 to 128. Okay, when you come to the second data type called short, The size is 2. 2, it can only store maximum size of 2 bytes. Means when you say a number and if you want to store it, it occupies some memory. That memory can maximum hold until 2 bytes. If the number exceeds more than 2 bytes, then the short cannot be stored. Then we should go for the next data type called int in that case. So for when we come to short, if the shorts are capable enough of storing the data, it would be like 300. And I'm just because I just copying these things. Okay, I will tell you how to compute it. This is something like we need to by heart, uh, but there is a calculation how we calculate it as well. When it comes to integer, normally for most we use integer and long in order to store the data types for integers. This is of 4 bytes. So how they're gonna ask you interview question is like, what is the size of a integer? Then you should say 4 bytes. Okay, normally it would be the multiples of 2. Width is a smaller one, which is 1 byte. Short is a multiple of 2 for byte, which is 2. Integer, it's 2 into 2 4. And next one, if you see, wait one, let me just add one more. And this is 4. This is long, and this is 8. And the range, I will tell you how to express this ranges. Let's say plus x2 plus 5. Okay. 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 How I will explain you how to calculate the range. Okay. Uh, Range of a data type formula is like, let me just, number of bits. To the power of, if I say symbol, it is the power of. So this is nothing but the range of a data type you calculate as number of bits available in a language to the power of number of bits occupied by the primary data type. So let me put it in this way to make you more understandable. How computer stores a data? How computer knows 2? 2 is the value. 2, 2 is this. Whenever you give an integer to a computer, it converts that 2 into its binary format. Like binary of 2 is like 1 0. Okay, it converts into 1 and zeros. Normally bits is either represented as 1 comma 0. Either value can be 1 comma 0. So when you say 2, it would say 1 0. 2 power 0 into 2 power 1. I hope you understand, right? 2 is represented in binary format as such a way equal to 1 0. How we calculate 1 0? Computer would take 2 as 1 0. Where 1, how we calculate it is like, this is equal to 1 1 into 2 power, like this, 2 power 1 plus 2 power uh, 0 2 power 1. Okay. I just don't remember the exact 2 power 1. How just uh, normally this is a binary code. We like an basic things how you convert a binary number into an binary normal integer into a binary format. How it is like if you multiply in such a way 1 into 2 power 1 plus 0 into 2 power 1. What is 0 into 2 power 1 is 0. 1 into 2 power 1 is 2. So they convert any number in such a way and they convert into bits 10 01 1011 1002. So a number can be represented in any of that way. Got it, Vishnu?
Yeah.
So when you convert, when you say 2 to a computer will automatically think, convert it into a binary format, saying, okay, 2 is always 10. It will add 10 with 3. 3 is always uh, uh, 1, 1 or something. Wow, 1 I guess. It is 1 1. So 1 means 1 into 2 power 1 plus 1 into 2 power 0. Something I don't remember how we convert. If you want to check, just check in Google how we convert a normal integer into a binary format. So it's a
Okay.
small formula. So computer knows everything only in bits. That is what I am trying to understand, tell you since long. Okay. When you say
Okay.
let me remove this. This might be a mistake. Okay. The formula. So normally everything is represented in bits. So any integer that you give will be converted into bits. Any content that you give will be automatically converted into bits, and all the manipulation happens only in bits and then transformed into the integer. So every language always use data types to convert this. Why Java got more prominent is, I forgot to tell you this earlier, why Java got more prominent is when we convert characters in C, the data types ranges very differently. Very differently means the memory that is being occupied for a character like English content is different to the Chinese content. When you store one keyword for a small information in English, if it takes 1 byte, the same content character is taking in Chinese, it is taking 2 bytes. So when we compare it, when we try to write code in different languages, the memory management and how the data types are defined for each language is varying in C. But in Java, for character, always they defined as 2 bytes. Even Chinese would maximum take 2 bytes. English, even though it takes 1 byte, they defined character as 2 bytes. So let one byte of data waste, it's not a problem. But Java supports all languages to write. You can write code for in Java not only in English. You can write in French. You can write in Japanese. You can write in any way. The code can understand that. Got it?
Yes.
Yes. So when we store the data, when you write a variable, when you create a class, when you do anything in Java, internally, when you execute them, when you run them, everything gets occupied within some memory. So when you create a data type, normally the data type, when it objects gets created, it allocates a little space of memory in the backend and stores those values. So when it stores the value, if I say a byte can be either one representing something in one zero. Okay. So when you say the when it represents in zero, so let me calculate the range. How we calculate it? In normal any language, the byte is available in the Java as 2, right? If you see here, byte is always represented maximum with. Oh, sorry. This is always byte is always represented with 2 because it's either you represent it 0 or 1. So maximum number of bytes available in this Java is always 2. 2 power Okay. Let us say, let's calculate the range of a data type with number of bits occupied in a primitive data type for byte. Let's say for one byte every one, so one byte is equal to 8 bits, right? One byte is equal to 8 bits. So number of bits occupied for a byte is, so it would be 8, because it's one byte, right? The size occupied by the primitive data type of byte is 1, so we should say one byte is equal to 8 bits. Okay, this is equal to 2 power 8 means it's 2 power 50, 256. When you say 256, this can range from 0 to a data can be from 0 to 256 by 2, means it can have positive or negative, right? If I say +1, an integer can also be -1, right? So they divide, if you say 1 plus 127 to minus 128, so you can represent a byte code maximum from plus 128 to minus 128 range. Got it?
Yeah.
Just this is a theoretical, uh, how uh, let me put it again in an easy way how you can understand. Maybe even I am not able to get it. If you have any doubts, you can read the material also and get back to me. Let us say if I give
Yeah.
you
It's
some
okay. No
object.
problem.
Okay, you are in a room, and if I give you an object means small item, and your room is of 10 square feet. Okay, when you place an object in your room, does it occupy some of the space?
Yes.
Yes. So same way, when you are writing a code and if you are creating a variable or anything, if you are creating an integer, will it occupy some space? It needs a space, right, to create?
Yes.
Yes. That is what earlier when I showed you on the first day itself, when I showed you one UI that was implemented by Java. If you install the latest version, you see this UI. So by default, whenever you run something in Java or write something in Java, it takes minimum memory. Okay, so always, even though I didn't write any Java program or running any Java program, Java is always taking minimum memory. If you see here in the browser, you will be seeing that memory is being occupied. On that day, you remember, right? Always we see the memory, at least little memory is being occupied always, depending on the type. See, these things gets on varied according to the processes they run. This data gets occupied, right?
Yes.
So the same way how you create boxes in a room, whenever you write a code, they get they those needs to have some bytes of size. So they classified the sizes, like say byte, the data is again classified into bytes. When you say integer, again first starting from integer, byte, the basic starting of any integer can only be with 10. So let us, why can't we classify 10 into bits? Bits is always 10. When we group all the bits, it becomes byte. So byte is ranged from plus 127 to minus 128 with the maximum size is 1 byte. When size gets increased, if your variable size is getting increased, next option is you have short. Short is also having a range. Okay, from this range to this range, if you have any data, you can use short. Okay, then if your number exceeds more than short, then please add your numbers into int. For int also you have a range from plus x to minus x. Okay, and this is a computed value. You can, if you substitute this in the formula, you will get it. If your number is greater than integer, in that case go for a long. So what I want to convey from this is, you can store a byte in a byte in short. Short can be stored in int, and int can be stored in long. But you can't go in a reverse order, because if you say I have a big integer which is capable enough in size of long, and if you try to place it in int, will it be fitted?
No.
No. See, for example, let us say I have a big item more than 10 feet, 10 square feet. And if you try to place it in your room, will it go and fit into your room?
No.
No. So they classified a data in such a way that they are categorized into four different integer types. In integer, they carry if it is very small, please use byte. If it is bigger than byte, go to short. If it is greater than short, go to int. If it is greater than int, go to long. Okay, maximum going for a long is sufficient. There would be no more data if greater than long. Long means how much value do you expect in a long? Long means 2 power 8 into 8. Got it? 2 power 8 into 8. This data plus x and minus x means 2 power 8 into 8 means the number. Let me show you in Google. What is the 2 power 8 into? Do we have power here? Where is the power? Okay. 2 power 16, it just 64, right? 2 power 64. See, enter the base 2 power 64. See, your number can store until this much number. Okay, if you divided it by 2, you can have means divide by 2 means a number can be either plus or minus, right? So if you divide it by 2, you can add it by plus or minus of this number by 2. Got it?
Yeah.
If some case, if you have an integer which is longer than this, how you gonna store? Then I go for a string. String is a content. I place it in a string and I store it in a string. String is just it won't store it as an integer. It will store it as a complete statement or a big content, big string. So maximum everywhere when you try to implement or use integers, you can use either three of them. Normally, maximum we use int and long for normal development stuff. Even bytes, I never used bytes. But who write algorithms? Who write small codes? See, if you have a task on bits, in that case, or converting a number to a binary and calculating something, in that case you use bits, and you do the process. But when it comes to an integer, using this much is to byte short, int and long is sufficient. Got it, uh, Vishnu?
Yes.
Okay. uh, uh, this is for an integer. Now let me go for float category. What is a float? Float is nothing but if you have something with a decimal points. Okay, float. Let me copy this. This would be useful. Float category data types. Here in float category, the data types is again classified into two different types depending on the type of decimals. Okay, let me say, just tell me how many decimal points did you experience till now in your lifetime? Vishnu?
Means like what?
Huh?
Like I didn't get you. How
How,
many times?
how many decimal points? When I say, uh,
One or two.
huh?
Maximum 5 decimal points.
How many decimal points did you see maximum in your lifetime for any point of time? Huh?
3 or 5.
Maximum 3 or 5, right? So can you
Yeah.
expect a situation where you have more than that?
Maybe.
Huh?
Yes.
Yes, yes. Let me put it into an example. Do you know the value of pi?
22 by 7.
22 by 7. If you calculate it, how many decimal points do you get?
We will take 2, I think.
Okay, let me just show you. Okay, see, normally when you say value of pi, we maximum compute until 5 decimal points, right?
Yeah.
3.14159 maximum. But to be frank, when we say value of pi, that is this much, right?
Yeah.
Can you see my screen?
Yeah. Yes.
Yes. But really, to be frank, value of pi is until 1000 digits, right? But
Yes.
in maximum, how we use is so Java. See, when we say someone has written Java, they too should have a restriction saying, okay, my Java can support this much of data. So for that, they gave maximum of until 16 decimal points. You can place a float category data type with 16 decimal points maximum. Okay, minimum can be 8 decimal points. Okay,
Okay.
got it. So minimum when it is 8, it means you have even 1 decimal point, you have even 2 decimal point. Like when you say, if you say, uh, when you calculate paisa, how many decimal points you get for a rupee? 2 paisa, 2 digits, right? 00.
Yes.
Maximum is from 00 to 999, right?
Yeah.
Yeah. So when it comes to petrol, at least they calculate not petrol, some other digits. When what do we have decimal points more? But you understood the context, right? So remaining digits
Yes.
would be zero. For suppose, let me define float. Float. Let me say uh, if I say I have a number called 3.1415. So this means remaining all is of 00, right?
Yeah.
That is the example. If you say 8 is a minimum, even though you declare 1 or 2, the remaining will be taken as 0 by Java. Got
Okay.
it? So never worry how many points. Maximum decimal point it support is 16. After here, it can support until 16 decimal points. So let me come to the data types. What data types we have in float? Okay. In integer, you have byte, short, int, long. Remember them. Okay. What are the data types you have in integer? Which is byte, short,
Right.
int,
Short. Int.
long.
Long.
Got it?
Okay. Yeah.
Just note down them. And in float, you have only two different data types,
Okay.
which is float and double. So let me put it here. And float category data types, we have two different like float, FLOAT, and the second one is double. And sizes is like 4 to 8. It stores 4 bytes, this stores 6 bytes, and ranges from again same plus x to I'm because these are big computed values. If you go into some theory notes or somewhere, you can find the values for this. I'm just not noting them. And the float supports 8 decimal points. Okay, and maximum supports 8 decimal points. If your decimal points increases than 8, then you should go for double. That is what I mean to say. Got it?
Yes.
Why they gave this many features? You can ask me one simple question. I mean, it's confusing, right? Why I should use float and double? Why can't they just give me double and say use double because it stores 16 decimal points? If I even store 2 decimal points in double, it's fine, right? Remaining will be
Yes.
0.
Yes.
Yes, even in the case of integers, Ravi, why can't we use only long instead of writing byte, short, int? because long supports all. Can you hear me? Okay, you can ask me like in integer why we need again four different data types in integers. Why can't we use only long? Why we need byte, short, int? Uh, you can ask me that question. It's a valid question. But think in the perspective of when you write a code and when you have a big system and lot of computing happens. If you store a small value in a long and waste lot of memory. When you create one long, it would automatically consume 8 bytes, right?
Yes.
But your data is very small where 2 bytes is sufficient. So if these variables are used in a long, it might be very small for you when you look at one instance. If your code is running 1,000 times, 2,000 times, or 10,000 times, or 20 million times, like Facebook has written a code, let us say in background they have created a long, and 1,000 users logged in at one point of time, and the code executes 1,000 times. So 8 into long 1,000 times means it consumed 8,000 bytes. But if really your byte is sufficient to only just use short, 2 into 1,000, it is only 2,000. At bottom, if you use long, it is 8,000. It's how many times difference? 8 minus 2,000 means it's nearly 6,000 bytes of memory was wasted without any use. Got it?
Yeah.
So that is the reason, depending on your data type, why you need to use excess of data when you know the data type, please. So if your data, if you think this data type variable is very small, just use small data type. If it is integer, use integer. Why to go and use long? If you feel there would be a chances of using long, because developer would be given always with a minimum and maximum.
Yeah.
So when you have when you know it, you write the code accordingly. That is the reason they have given us different types in each integer, in float, same way with character and string as well. Got it?
Okay.
Okay, that is the reason. So when you know that, okay, maximum possibility of decimal points in my project should be not more than 8, then go for float. If you feel there is a probability that my variable can get a value of decimal points more than 8, then go for double. Got it? So
Yeah.
when we say how we define the syntax for this float is, we would f should be small, float. Okay, float f should be small. Float f equal to, let us say, 10.75 f. Got it? F
Yeah.
means f means represents, this is a float value. Okay, how it stores in the memory is, when you create when you initialize your variable such a way, in the heap memory there creates an object with f, which which would be storing the value like this, small f. The variable is small f. It would be like 10.75. How many decimal points by default a float will have? 8. So it will have remaining 6 digits as zeros. Got it?
Yeah.
So in the same way with the double, for float by default you should define as f. Okay. For double there is no need of defining anything at the end. For the double it will be like DOU. The syntax will be double D small, double D equal to, for let us say D equal to 10.75. If you define this way, how double stores is, in D there would be an object created in heap memory such a way that 10.75, how many digits decimals will be 0? All the 14 digits will be 0. Got it? In memory, the 10.75 will be stored in this way. Hello, Vishnu?
Okay. Okay.
Okay.
Yeah. See.
Yeah. So that is the way how they classified the data types. Why these many data types in internally they came is like this way. Same way. Next, you have time or I think we already crossed more than 1 hour. Hello, Vishnu? I think you were speaking on mute.
Yeah, I'm sorry.
Uh,
uh, we can end the class for today.
yeah.
You and I should
Okay.
go.
Yeah. Anyway, if I start one more, we should end it at the middle. I would say just go through the material until data types, until float. Just don't forget. I gonna ask you many questions. Go through those material for sure. You make time for yourself while traveling or some other time. Read them. Okay.
Sure. Okay.
Okay. So just remember these data types, and I'll ask you questions tomorrow. Got it?
Okay, Ravi. Okay.
Fine.
Thank you.